So practice problem number 1 in notes 3 says this. The volume of a liquid that fills a flask is 750 cubic centimeters. The mass of the liquid is 525 grams. What is a liquid's density? Is it most likely to be water, gasoline, or ethanol? So you'll notice that there are 3 sections underneath this problem, one for data, one for work, and one for solution. I structure all of my problems like this because I think it's a very effective way of laying out all of your data, making sure that you're doing the work properly, and then finally coming up with a solution. Just being organized is a really great way to tackle some of these problems later on, especially once they get a little bit more complicated. This problem right here, not terribly complicated, so let's go ahead and jump right into it. The first thing we're going to do is we're going to find all of the numbers that pertain to us or are in the question. So the first number that I see here is going to be, let me go ahead and decrease the font size here first, 750 cubic centimeters. So I'm going to just go like that, cubic centimeters. Or actually what I can do is go like this. There we go. And the other number that I have is 525 grams. So now what I want to do is, once I've written down all of my numbers, I want to figure out what is the question asking for. So I look at the question and I say, what is the liquid's density? So the other thing we're going to write is density is equal to, well, we don't know yet, but we at least know what we're looking for. In the work section, we need to realize what was the thing that was given to us. What was the formula that was given to us to calculate for density? Well, if we remember, density is equal to mass divided by volume. All right, mass divided by volume. So going back to the data though, let's find out what each of these means. Like, what is cubic centimeters? What is that a unit of? Well, that is actually a unit of volume. So volume is equal to 750 cubic centimeters. And 525 grams, well, that's a unit of mass. Okay, so mass is equal to 525 grams. So to solve for density, abbreviated letter D here, we need mass and we need volume. So all we have to do is plug in the values for mass and volume to figure out what this is. So D in this case, density, is equal to 525 grams divided by 750 cubic centimeters. All right, let me go ahead and write that out. Cubic centimeters, like that. Okay, you plug that into a calculator and you'll get 525 divided by 750 gives me 0.7. D is equal to 0.7. But you can't stop here because you need the final unit in your answer here. So 0.7. And how would you calculate that? Well, you just take a look at the values that you're using here. 525 grams divided by cubic centimeters. So the answer is grams per cubic centimeter. Just like that. And that's actually the solution. So I'm going to go ahead and copy that over here, or just move it over here. And then the second part of the question is, what is that most likely to be? Is that water, gasoline, or ethanol? Well, taking a look at water, water is 1 gram per cubic centimeter, gas is 0.7, and ethanol is 0.79. So this is most likely to be gasoline. Practice problem number 2 says, certain compounds called aerogels form rigid, lightweight foams that can support a mass many times greater than their own. If a sample of an aerogel has a volume of 87.3 cubic centimeters and a density of 0.25 grams per cubic centimeter, what is its mass? So the first thing you want to do, just like every other problem, is to write down all of the things that are known to you. So write down all of the numbers and to identify what they are. So the problem states here we have a volume of 87.3 cubic centimeters. So that's the first piece of information that I'm going to put down. And we also have a density of 0.25 grams per cubic centimeter. So that's the second piece of information that I know. All right, so I write down all the data. And then also, it's good practice to also write down what are you looking for. We are looking for mass. That way we know when we write down our equations, how can we structure our equations so that we isolate just the thing we're looking for. So given that, we need to identify what is the equation for density that we know, and we know that density is equal to mass divided by volume, and I need to isolate mass by itself. And so if you're good at math, you can kind of see how we did that. Mass is equal to volume times density. If you're not so savvy at math, that's okay. I'll explain how I did that. Basically, if I need to get mass by itself, volume is stuck on this side with the mass. It's stuck in the denominator. So to get it out of the denominator, I multiply both sides by volume. and the volume actually cancels out here, and then we get volume times density is equal to mass. So I just rearranged it on this side as well to show mass is equal to volume times density. Okay, and so when I set it up like that, I can actually just plug in the volume and the density into that equation. And then when I do that, I finally get a solution. You can put that into a calculator, and that solution is, I believe it was 21.825 grams in a calculator. But if we were worried about sig figs, the mass will be rounded up to 22 grams. So that would be the correct answer, 22 grams for the mass. Problem number 3 says, Carol says the distance from her house to the nearest movie theater is 7,920 feet. What is this distance in miles, and what is this distance in inches? So now we're discussing our dimensional analysis problems and converting from one unit to a next unit, both measuring the same type of measurement. These are both measuring length, or in this case we have 3 different things for length. We've got feet, miles, and inches. So this is where it becomes appropriate to kind of know and distinguish what unit you're using to describe your measurement. In this case, it's really hard to picture what 7,920 feet looks like, but you can kind of gauge that in terms of miles. So let's go ahead and start this problem off just like we start off any other one. We're going to write down the only number that we have, 7,920 feet. Okay? And that is my length, but we don't really need to write that down. We also need, how many miles is that? Or let's write it a little bit different. Feet to miles. So we need to convert feet to miles. And then we need to convert feet to inches. Okay, so let's go ahead and split this off into 2 different work areas. I'm going to go right here, split it down in the first part. The first question is, how many miles is that? Well, let's go ahead and start off our bridge problem, 7,920 feet. And I'm going to go ahead and just draw my bridge here. And I want to convert that into miles. And so, do I know the conversion factor between feet and miles? Well, I personally do, because I learned it when I was in school. Not a lot of students are taught this anymore, but going from feet to miles, I need to know how many feet are in 1 mile. I know that the conversion factor, I'm going to write it here, 1 mile is equal to 5,280 feet. Okay? The other conversion factor I'll need later is that 1 foot is equal to 12 inches. Okay? So I'll need both of those later. So this conversion factor, I have to put it right here in this spot, but I need to make sure that I am canceling out the unit that I don't want and leaving the unit that I do want. So to cancel out feet in the numerator, I have to put feet in the denominator. So that's why I'm going to put 5,280 feet in the denominator and just put the other one in the numerator, 1 mile up here. Okay? And the last step is to just double check my unit here. Do feet cancel with feet? They do. And then I'm left with the last unit that I want, which is miles. Multiply everything on the top, multiply everything on the bottom, and then do top divided by bottom. Okay, so 7,920 times 1 is just 7,920. And then 5,280 by itself. And that is going to give me an answer of 5,280. 1.54 miles is what you should have gotten here. So I'm going to go ahead and put that in a new spot. 1.55 miles if we round correctly. Okay? So the second part of the question is, what is this distance in inches? I'm going to go ahead and start off my bridge problem like before. I'm going to write down my number that I'm starting with, 7,920 feet. Let's go ahead and draw in a bridge here. And put in the conversion factor. So the conversion factor again is 1 foot is equal to 12 inches. I want to get rid of feet and leave it in inches. So I'm going to put 1 foot is equal to 12 inches. Okay? Double check that my units cancel and I'm left over with whatever I want. I have feet cancel with feet, and that's good. And in this case, I multiply the top, multiply the bottom, do top divided by bottom. So 7,920 times 12 divided by 1. But I don't really need to write that. If you understand that dividing by 1 will just give you the same answer, I can just leave it as 7,920 times 12, and that gives me an answer of 95,040 inches. Okay, so those are my two answers. 1.55 miles and 95,040 inches. Problem number 4 says a grocery store is having a sale on ice cream. You can buy a pint for $2 or a half gallon for $7. Which is the better deal? And the conversion factor for pints to gallons and quarts was given to us. 2 pints is equal to 1 quart, and 4 quarts is equal to 1 gallon. All right, so this is something that you might actually run into in the future, is bulk sales, or understanding if a bulk item is actually cheaper or not. You can kind of do these quick conversion factors on your calculator on your phone pretty quickly. So what we need to do is compare the pint cost to the half gallon cost. And so we need to convert one of these to the other. We either need to convert pints to half gallons or half gallons to pints. All right. So in this case, I think it's easier to convert the gallons into pints. So what we know is that, let's go ahead and start the work here. We're doing a bridge problem. So we're starting with a half gallon. A half gallon in decimal form is 0.5 gallons. All right, and I'm going to go ahead and start my bridge here. And the first conversion factor that I have here is going from gallons to pints. We weren't given a conversion factor that goes straight from gallons to pints. Instead, we were given gallons to quarts and then quarts to pints. So if we want to get rid of gallons, we first have to convert to quarts. So let's go ahead and do that. I'm going to go ahead and put in that 1 gallon is equal to 4 quarts. And again, the reason why I'm putting gallon on the bottom instead of the top, why didn't I put 4 quarts on the bottom and gallon like this, is because if I want to cancel the gallon as a unit, I already have it in the numerator, so now I need it in the denominator. All right, so let's just go ahead, cross out the units as we go. Gallons, we'll cancel the gallons. And now my final unit that I'm left with so far is quarts. But we're not done yet. We have to get to pints. So now we can actually do the second conversion factor. We have 2 pints is equal to 1 quart. So I'm going to go ahead and put in another conversion factor. If I want to get rid of quarts, I'm going to put 1 quart is equal to 2 pints. Okay? Check my units, see what cancels. Quarts will cancel with quarts. And then I am left with pints, and that's the final unit that I want. So I'm going to leave that there. The next step in the bridge problem is multiply everything on the top, multiply everything on the bottom, do top divided by bottom. So if I do 0.5 times 4 times 2, that is going to equal to 4. Okay? And then if I do 1 times 1, that just gives me 1. So what am I left with here? I am left with 4 pints. And for the bigger size, 4 pints was equal to $7. So that was $7 for 4 pints. So let me go ahead and put that in. This is the big size. For the smaller size, let me differentiate that with a different color. Let's do blue here. The smaller size was 1 pint for $2. 1 pint for $2. Many of you are already seeing the connection here. If I need to get to 4 pints, how much is that going to cost me? Multiply both sides by 4. I end up with 4 pints for $8. So what's the better deal? Technically, if you can eat all this ice cream, the half gallon, the better deal here is the half gallon. So let's go ahead and put that in the answer. Half gallon is the better deal. All right, there we go. That is practice problem number 4. Practice problem number 5 says a typical sedan weighs around 3,400 pounds. What is this weight in tons, and what is this weight in ounces? So before we begin, I'm going to give you the conversion factors between those two because they're not necessarily known. 1 ton is equal to 2,000 pounds. And 1 pound is equal to 16 ounces. Ounces is abbreviated OZ. The other thing we need to know is we have our starting weight, which is 3,400 pounds. Okay, so let's go ahead and do our first conversion factor, which is converting this into tons. So I'm going to write down my starting number, 3,400 pounds, and start building my bridge. So I know I'm going to need, let's go this way, and then like that. Okay, if I want to convert from pounds to tons, this is actually pretty easy. I'm going to use this first conversion factor. I have pounds here in the numerator, so I need pounds here in the denominator. I'm going to put 2,000 pounds right here. And that leaves me putting with 1 ton on top. Okay? So let me go ahead and calculate that. If we do 3,400 times 1, that gives me 3,400. And then 2,000 is by itself on the bottom. So that gives me with an answer of 1.7 tons. The second part is, what is this weight in ounces? So I'm going to start off with another bridge problem, 3,400 pounds. Start building my bridge. Again, another pretty easy conversion factor. We're going to end up with a much larger number this time, though. I want to get rid of pounds and end up with only ounces. So I know I need to put pounds in the bottom. 1 pound is equal to 16 ounces. 16 ounces. So if I do 16 times 3,400 in a calculator, I get a pretty big number here. And that is going to be 54,400 ounces. So those are my two answers, 1.7 tons and 54,400 ounces. That is practice problem number 5. Practice problem number 6 says, how many kilograms are there in 100 grams? So this is going to be our first metric conversion problem in these practice problems. The data is pretty simple. We're going to just put down that we have 100 grams. And what we want to do is, for the work section, I'm actually going to use this little chart that we have in our notes. First, we want to identify where we are in the metric conversions and then where we want to go. Okay, so we start off with 100 grams, and grams is our starting unit. And where do we want to end up? We want to end up with kilograms over here, kg. So where are we on this step chart in terms of grams? Well, grams is a base unit, so we're going to put it right there. Okay, and then I'm going to go ahead and use a highlighter tool here. If I'm starting here, and then I want to go to kilograms, I'm going to divide by 10 for every step, because base is here, kilograms is up here, and I'm going up. So I'm dividing by 10 1, 2, 3 times. Okay, so I take 100 and divide it by 10 3 times. So I'm going to go do 100 divided by 10, which gives me 10. Then I do my next step, which is 10 divided by 10, which gives me 1. And then I need to do it one more time. So I'm going to do 1 divided by 10, which gives me 0.1. Okay? So 100 grams, I'm just going to go ahead and put the units here as well, is equal to 10 decagrams. 10 decagrams is equal to 1 hectogram, and 1 hectogram is equal to 0.1 kilograms. Okay, so my answer here is that 100 grams is equal to 0.1 kilograms. And that is practice problem number 6. Number 7 says, Pikes Peak is a mountain in Colorado. Its height is 4,301 meters above sea level. What is this altitude in kilometers? So once again, I'm going to just write down that we have the number 4,301 meters, and I'm basically just using this chart again to convert it. So going from meters to kilometers, we have to understand that meters is another base unit. So we're going to start off right there at this base unit, and then we're going up to kilometers again. So this is very similar to the previous problem. We're going from base to deca, deca to hecto, and then hecto to kilo. And for every step that we jump, we have to divide by 10. Okay, so let's go ahead and write that down. I'm going to put 4,301 meters divided by 10 is going to equal 430.1 decameters. 430.1 decameters is equal to, well, let's divide by 10. And that is equal to 43.01 hectometers. And 43.01 hectometers divided by 10 for this last step is equal to 4.301 kilometers. And so that's my final answer here. If I go 4,301 meters, that is equal to 4.301 kilometers. For problem number 7 and problem number 6, there is a pretty good shortcut. If you just memorize that going from the base unit to kilo is a conversion of 1,000, so like in this case we're dividing by 1,000, then that's something that's really easy to remember. There's a few of these that would be really handy to memorize. We know that going from base to kilo, that's 1,000. Base to centi, you're multiplying by 100. And then base to milli, that's the third one. If you can memorize those three, that'll be actually really helpful for you in the future and kind of make this process a little bit faster. So base to milli, that's multiplying by 1,000. Base to centi, multiplying by 100. And base to kilo is dividing by 1,000. Practice problem number 8 says, Laura runs a 100-meter race in 20 seconds. What is her time in kiloseconds, and how long is the race in kilometers? So this is a two-parter. We're going to keep this graph a little small here just because we've got a lot more work to do this time. We've got 100 meters as our first unit, and then we've got 20 seconds, okay? And we're looking for kiloseconds and kilometers. Both of these things are going to be base units. Okay, so instead of doing this ladder method, I can still do the ladder method, but we're going to try to use that conversion factor going from one kilo unit, let's say 1 kilometer, that is going to equal to 1,000 meters, or 1 kilosecond is going to equal to 1,000 seconds. Okay, and so you can kind of see the pattern here is that 1 of the kilo is equal to 1,000 of the whatever you're measuring, right? And this can be applied to anything. It could be applied to grams, liters, or sometimes even money. Like 1K, some people say, let's say kilo dollars, for instance, is equal to $1,000, right? So this is something that people say. And it still applies. It's the same conversion factor. So if we're going to keep this logic, we can kind of apply a bridge problem to this. If we have 100 meters and we want to convert that into kilometers, still do a bridge problem. 100 meters, and we want to get rid of meters, so we're going to put 1,000 on the bottom, meters, and that is equal to 1 kilometer. 100 times 1 is 100. Meters cancel with meters. And then divided by 1,000, the answer for that is going to be 0.1 kilometers. Okay? And in this case, we've got 20 seconds. If we're converting seconds to kiloseconds now, the second part of the problem, I'm going to set up a bridge problem again. We want to get rid of seconds, so we know that 1,000 seconds is equal to 1 kilosecond. Multiply the top, multiply the bottoms, top divided by bottom. Okay, so and seconds cancel with seconds. All right, so 20 divided by 1,000 is going to give you 0.02 kiloseconds. So let's go ahead and type that in. 0.02 kiloseconds. So that's the solution for practice problem number 8. So Practice problem number 9, which is going to be the last one for this set of notes, says one of the smallest nations in the world is Liechtenstein, a tiny country between Switzerland and Austria in Europe. If its area is 160 square kilometers, how many square meters is this area? And they give us a hint here. Because 1 kilometer is equal to 1,000 meters, 1 square kilometer, not cubic, but square, is equal to 1,000 meters squared. So 1 million meters squared. So effectively, what they've done here is they've given us this conversion factor. So we've got this piece of data. We have 160 kilometers squared, and we want to know how many meters squared that is. So basically what we're doing is a very simple bridge problem where we have 160 kilometers squared, and we want to convert that into meters squared. So let's go ahead and set up our bridge just like this. And what I'm going to do is put, let's go ahead and write out this conversion factor once again. 1 kilometer squared is equal to 1 million. I'm going to be careful with my zeros here. That looks right. Meters squared. Alright, so to get rid of kilometers, I'm going to go ahead and put that 1 km down here. Km squared. So 1 square kilometer is going to equal to 1 million square meters. Just like that. Okay? And again, the reason for putting kilometers on the bottom, square kilometers, is because I already have it on top, so I want to cancel it out. My units in this case do cancel. And so what I have to do is multiply the top, multiply the bottom, do top divided by bottom. But in this case, I'm just going to be dividing by 1, so it really doesn't matter. I'm just going to do 160 times 1 million. And the answer that I get here is going to be 160 million. I'm going to go ahead and put in commas this time so it's easier to see. 160 million meters squared. And that's the answer to number 9.